Okay, we're gonna go ahead and get started. Thanks everyone for your patience. Others will be trickling in, I'm sure, but at least want to get the introduction part out of the way and turn this over. So my name is Steve Montgomery with Building Point Northeast, and again, thank you guys for joining our X7 webinar series. This is series number 1 in what will be a continuation throughout the next 30, 60 days, where we focus on the power of the X7 as it relates to the various trades. Today, this one will be focused more around the power of the tool for concrete contractors, general contractors, construction managers. In the next series, we will be focused heavily on the mechanical, electrical, plumbing, fire protection trades. With that said, I would encourage even those of you who are part of those MEP trades that are in this one to hang around, because a lot of what you will see today is very transferable to the other trades and applicable to the types of work that you do. Handling the webinar today is Steve Ostrowski. Steve is a sales engineer for the mixed reality and scanning portfolios inside of Trimble. He has been with this X7 since the beginning, and quite the subject matter expert as it relates to it. I would like to encourage you guys question and answer throughout this, so feel free to type those into the box and we will respond as we can, or at the end we will just open it up for Q&A. And one other item is I will be posting in the chat window. There's a good article that was released this week by AGC. It was not a Trimble driven article, and it was on Mortenson, joint venture Mortenson and Skull, using an X7 for quality control and quality assurance. So I will post that, the link to that in the chat box if anyone is interested in that. So with that said, I'm going to turn it over to Steve, and I'll keep an eye on the questions and answers.
Thank you. Thank you.
Yep.
So good morning, everyone. Steve Ostrowski here. Just to give you a little rundown, I'm going to do a couple slides. I know I recognize a lot of the names, so you probably have seen these and I've probably said them to you, but just in case, I want to make sure we kind of cover quickly what the X7 can do. Then we're going to do a live demo of one of our new features, the floor analysis. This is just going to be a live demo in my office, which means it's going to look small scale. But again, remember the X7 shoots up to 80 meters or 260 feet. And you would typically on a project pick it up and move it around. That's one of the big advantages with the in-field registration. So it's going to be like a localized presentation, but imagine this on larger scale. After that quick live demo, we're going to open up some data that we collected with Local 404 up in Cleveland to show an FFFL. So we kind of have two new features, and I'll discuss this with 5.8. One is targeted at, I'd say, general contractors and the concrete guys. But the other one, which also helps those guys, is for everyone. And I'd say it's actually really great for MEP. So yeah, short introduction, scanning, mixed reality. I was the product manager for both solutions and then came on to sales because I really do think both these solutions are so easy that even I could sell it at my, I'd say, less than polished presentation self. It really is turnkey. It's very moving data from TFL to AutoCAD or to Revit. It comes directly off the tablet. And then bringing that model data back into the mixed reality, you just drop it in Connect. So it's pretty easy. I do most of these demos live because I like to show how quick and easy it is. What we're showing today is just the X7. This works. I'm going to be showing it on my PC to share it, the tablet or the software that runs it. Field Link on my tablet, excuse me. But the T10 operates all of our other layout instruments. So the scanner, typically this was always a passive instrument. It would collect millions of points in a couple of seconds, and then you'd have to analyze it. But because the X7 has a laser pointer on it, we're able to use it like a layout instrument, like the RTS or the 986, to lay out high and low spots, which is what I will show you. It is not going to be faster than those instruments because it doesn't shoot to a prism, and it shoots a red laser. So for those of you on the call with existing 573s, 673s, or 986s, you'd probably be better off collecting the data for cut fill or contouring creation. So you can use this on aggregate, dirt, or concrete, scan it, find the high and low spots, and then create layout points essentially that you can lay out with those other instruments and hopefully be a little bit faster. That being said, you can use the X7 like you're going to see today. The other projects I covered, or the products, are the mixed reality. So the XR10, which would be the indoor augmented reality. So overlaying the model inside. I actually do that here in my own house after I created a model from the scan data, as well as sight vision, which is using an AR phone to display it outdoors. You can use the AR inside, but you just lose the GPS that makes it super accurate. And then the next thing we're moving into, as always, is pushing the bounds in Trimble, is construction robotics, which I'm sure some of you have seen some of those videos that we've seen. 3D scanning has always documented the as is. It's very accurate, and it's going to help with pre-construction planning and field measurements for renovation and retrofits. This scanner improves upon that process because you're doing the registration, refinement, and exporting all on the tablet out in the field. So you're able to ensure that you have the correct data, you have all the data you need, and you're able to move on. That being said, because we're using FieldLink and you're able to import SketchUp models, AutoCAD, DWGs, Revit models, even Navisworks, we have a way to bring those in. We can bring scanning to new construction or during progress of construction as well, because we're able to scan and compare to the model. That is going to be the second part of what I show today. The other thing we're able to do is help with project deliverables. So on the surface analysis, the floor analyst, we're able to actually do an FFFL report, an ASTM E1155. We can also do measurements to make sure that your ADA ramps are built correctly, as well as document where your sleeves are, if they're in before the concrete was poured, or if they're missing as well. So it's really something that we're pushing as a project scanner, is how I would like to see it. We have a whole bunch of software that can help with specific tasks. This, and what I truly believe is what you can start out on, is just FieldLink, because you can export as an RCP directly to AutoCAD, Revit, or Navisworks, even section view it as so smaller data sets, because the scanner will collect everything. But the other softwares we can have that will help, are like Cloud Engine was new release for us. That's going to help you publish and share your data to your customers. Scan Essentials for SketchUp is great for the GCs who want to bring in scan data of a site and quickly plan it out. Think of it like rough modeling. That's actually how I model my house to show the XR10. And then there's RealWorks, which is really, I'd still say, the base of all of our scanning in Trimble. So it's kind of what we pulled from for FieldLink to do a lot of this. But it will do advanced registration, analysis, and modeling, as well as many other things as well. But you typically only really need FieldLink to get started and actually be profitable with it. So for those of you who aren't familiar, what is FieldLink doing? What you're seeing here is actually a collaboration model, and then a couple sets of data, actually pre and post pour on a concrete floor for elementary up in Mead, Colorado. So what we're able to do is scan before to make sure the sleeves are in the right spot, and scan after to make sure the depth of the concrete is correct in essentially the entire floor, as well as do comparison. So this is kind of a quick GIF to show you that. The scanning is taking place at each one of those triangles. So depending on how open your site is, you can move 50, 70 feet in between scans if it gets you enough overlap. In my house here, I've walls are already up, so you're kind of scanning in each room, but hopefully what you can do is time when you get out to project so you can get there before the sheetrock is. So you can essentially cover more space without scanning as much. That being said, it typically only takes anywhere from 30 seconds to, depending on what type of scans, 5 minutes per scan to collect images, or scan and collect images can be about 2.5 minutes in the shortest time, but we'll actually do that here and show you what it looks like. And that's my 5 minutes on the preview. What am I showing today? For 5.8, we have the improved, I'd say, in-field registration, refinement, and referencing. How do we align the scans to the model? And then as well as how do we connect those scans together? We also show the scan to model a bit better. We have some improvement in the section boxing. So scanning will collect everything it sees up from one station up to 260 feet away. Section boxing is going to be able to bring that down. We've improved that a bit for viewing. Excuse me, as well as exporting to RCP or RCS from that. The new features are the floor analysis, which I'll show first, and then the scan to model inspection. That scan to model inspection is for everybody. We're going to use a little more kind of documented use cases for GCs and concrete guys, so flat. If you don't have models, if you just have a plain 2D model, that's fine for flat work. If you want to do vertical work, we can get you that as well to kind of show you lean. If you're an MEP guy, if you have the collaboration model, you can scan and compare to make sure, like you see on the bottom here, that everything is actually in place. And it'll give you a little key showing you that. So let me jump in here. So floor analysis. I'm showing you on a local site, just one scan, it's going to come in, and then we're going to lay out the high spot that I have on my ground here. But please try to remember that you can cover a full floor, multiple scans, multiple sites. It works on aggregate, wet or green concrete, as well as dirt. Pretty much anything it can capture. Anything but water would be my kind of knowledge. We then can create reports. So we create 2 reports that I'll show. An ASTM E1155 FFFL report that matches actually what we did with the dipstick here. And then a cut fill surface report, giving you the idea of how much is above and how much below. And then you can lay out these grid points. So these grid points here and what I'll be doing here will be small, but please try and think of them on a larger scale. You can spread them out to every 3 feet. And then you can lay out those grid points. They get their elevation from the closest scan point with either your 573 or your 986, et cetera. The next one we'll show is the scan to model inspection. This is fairly easy. No, I guess I forgot to switch the pictures, but I'll show that really quickly. Essentially what it's going to do is compare what is actually built with what was modeled. All right, so it's going to do a comparison between that, or find the closest model point to the closest scan point, and actually give you a grid kind of spacing of what that looks like. So here would be an example of an elevator tilt. But enough with the slides. That was 10 minutes longer than I wanted. So we're just going to go in to actually start scanning here. I've done a node data setup already in my room. I could set it up with control points if I had it, but I'm actually just going to go ahead and jump in and start scanning. We're just going to do a fast scan. So a minute 35, I could put it on a layer as well if I wanted to, but we'll just start it off. Now, the reason why I like to show this live is actually essentially how quick the workflow is. The first minute though is huge. And one thing I really want to make sure everyone realizes, this scanner, without even the workflow improvements of Field Link and being out in and using the laser pointer out in the field, has a great hardware improvements, including what it does first. It levels itself, so it'll turn back and forth to 3 seconds. So most scanners level themselves to a couple minutes. This will actually level itself to 3 seconds. So even our higher end scanners don't have as good a level data as this. It's actually comparable to your RTS level data. So no more tri-brack. As long as it's set, you're good to go. The next thing it does is it self-calibrates. Self-calibrates itself before every scan, ensuring that the data is good. So you don't have to send it in for a yearly calibration. Typically that would cost on your scanner $3 to $5K depending on manufacturer, and then you'd have downtime as well. So this gets rid of that. And that on top of the improved high definition kind of dynamic scan range means it'll pick up pretty much anything dark or reflective when you're within 100 or so feet. Right now it is actually scanning. Once it's done, you're going to see it transfer over to my Field Link here on my desktop. Again, this would actually be done on the T10. So that high dynamic range of what it's able to collect is what allows us to scan wet concrete as well as HVAC very well, cast iron pipe, kind of things that were difficult for scanners before. This scanner actually picks up great. And it is a time of flight scanner, so range error of 2 millimeters means it's less than a 16th of an inch accuracy on all the points it's just collected. It actually just collected, when I was talking there, 12 million points. So in about 24 seconds, when it's actually scanning, it'll collect. Once it's done collecting, it's gonna write to the SD card, and then it's gonna transfer over to the tablet. So any questions so far? It looks like I lost the, I assume not, so we'll keep going. So you have redundancy of data. There's some on the SD card here, but really the data that comes into the tablet is what allows you to analyze it and actually use it. So once it's importing, we'll move into the floor analysis. It looks like. So here is my scan. I have, it's actually set up. So there's my station. This is my office. You can see my ceiling, but I can actually close that off and start to take a look inside at my floor here as well, in an elevation view that we can change. I'm going to jump into the floor analysis tab though to show you that workflow. So here I'm actually going to kind of define the area with a section box that automatically opens to define my floor area. Then what it'll go through now after I download it, it'll actually extract out all the points from the scan. So it does two things. It extracts out all the points because what we're showing you on the tablet generally is a preview scan. When you go through this operation, it's going to extract out all the points and do a floor analysis. So it's only going to grab the points that it determines is a flat floor. This is much like the same floor analysis that actually runs in RealWorks. That is the same. What do you do if the SD card gets full in the middle of a scan job? I would plug it in and delete it because you already have the data on the tablet. We do have, you can put in another SD card and you're fine. Sorry, I just wanted to answer this question that came through. So you can switch it out or delete it. I typically like to hold everything on the SD card and just have multiple ones. But yeah, back to the demo here. So here we've already gone through and defined out the entire floor, and you can see an intensity here, kind of the flat floor of it. I could come in here, and if my room is large enough, I could draw a FFFL line, but it isn't. And for an FFFL line, you actually have to have a minimum of 11 foot or else it doesn't count. So I will show you that on another set of data. But what I can do instead of doing the FFFL is contouring. What this can do is I can actually set the resolution. And so it's going to create a grid of points. We're going to do it fairly small. I can set a reference elevation. I already did that at 0, and then a tolerance. So what's going to happen is everything that is a quarter inch higher than 0 is going to be in red. Everything that is lower is going to be in blue, and everything tolerance is going to be in green. And it's going to create a grid of points every 2 inches, and then find the nearest scan point to give that elevation. So this is a small local site. I've done this my entire floor, as well as multiple scans actually works, but for the live demo, kind of makes sense to do it this way. And so once those contours are created, it'll have those grid of points. I could then lay out those grid of points with my other instruments, the 986 or RTS, or after this comes in, I can actually lay it out with the X7 as well. So I'll give that a second. So here you can see high and low spots, and I can actually click on those areas, and it will point to, and sorry for this kind of, it will point to the high and low spots. So there you see my daughter's, I guess, baby iPad. You can never start them on technology too early, I guess. And you can point to that and essentially tell someone to go smooth that area, whether it's aggregate or wet concrete. That's how quick it is. Now, this is a small local area. If you can imagine doing that 1.5-minute scans in a larger open area, you're probably done in covering probably 5,000 square foot in a couple of minutes, and then you can actually start to lay those out. So that's the cut fill, it can be used on any surface, pretty much any type of flat surface to high to low. What I'm going to open up next is actually the FFFL portion, and then we'll show you a little bit of that scan to model inspection. Any questions so far on this? The final thing I would do here, if I can actually zoom back over, would be to create. So after I do that, I can actually create a report. This report would look something like this, which is a surface report or a floor report. And this is an example showing you the number of points created, reference elevation, number of points high, number of points low, and then volumetric differences. So you can actually see how much concrete you're going to waste if your aggregate is too low when you're pouring that to a certain elevation. So that's one of the reports done. And then we'll jump into another actually data set that we collected with the local up in Cleveland, local 404. And what we did there was we actually scanned when they were laying their formwork. So they were just doing a manual pull, just to keep the third years busy during the winter, essentially. They then put aggregate and flattened it, and then they were gonna pour concrete and actually do a super flat floor. So here you can see kind of what the finished floor looks like. And we compare this to a dipstick. A dipstick is the traditional way to measure the FFFL. Scanning matches that with, I'd say, a couple more advantages as well. So you can see that I'm actually scanning at different progress or processes during the project. So if I come here, this is actually when they're doing the formwork. I can scan and compare top of formwork to a model. Works for ADA ramps as well. And this would work for all you MEP guys. And then this is actually when it's wet concrete and when it is actually just aggregate. So for the finishing out the floor analysis, I've already done this with the, I've already created the floor with the actually last scan. So I can actually just open this up and show you guys what it looks like to draw some lines. So I've already edited, drew some lines on the different pads. So they did a competition, 3 different groups trying to see who could pour the flattest floor. One of the big advantages scanning has over, I'd say, the dipstick is where these lines are sampled. When someone's manually going out and measuring with a dipstick, they may give you a PDF report kind of drawn over the grid lines of where they collected, but it's not exactly accurate. And you can see even by slightly changing the by a couple inches where your collection points are, you're going to get a pretty significant different answer. Now these floors were super flat and done really well by the guys, especially the middle group. But if I had to hit a 50 floor, you can see this 4988. If I were to move this a couple inches to this, I guess this would be the east here, it would change and give me a pretty significant different answer. Which would now be a 6294. So that's how much you can actually change by sampling different lines. Once you're done with that, you can create a report, and that report would actually look something like this, if I can open it up. And you can hand this off. So this is a flatness report actually with all the lines compared to a dipstick. You would set in the standards of what your overall FFFL were, as well as the min standards. So a 60-40 floor with the minimum values that they can hit there, and see if they pass or fail. In this case, actually, 2 of the floors did really well, and actually one of them did pretty well, but had, I guess, a rough spot to compare to. That's it on the new floor analysis tab. This inspection tab is, I think, applicable to everyone on the call, even if you're not a concrete guy, even if you're not a GC. I think it's very valuable for concrete and GCs, but I also think it's very valuable for everyone. So here you can see some blue lines. I actually, within 40 minutes, scanned once, was able to create the model that you see here if I turn it on in blue. It's in SketchUp, I just brought in the data. It's a square wall, so you can push, pull, and actually draw the fit like you see here pretty quickly. But one of the big advantages, I think, is actually just looking at a scan to model comparison. So what I did here was actually created a section box and then ran through and said, hey, compare everything to the closest model, everything in this section box, all the points there to the closest model component. And so everything you see here on a super flat floor is obviously within an inch, but I can bring this down to, let's go with half an inch, and you can start to see kind of the play of a flat wall to a very fine degree. So you can see within an 1/8 inch and a quarter right here. If I switch this to the aggregate, or no, we'll go with wet concrete first. You can actually see how it changes from when they were going through their finishing routine to make it super smooth. So you can catch this when it is wet. Generally what will happen on these super flat floors, they'll pour it, screed it with a laser screed. That should be very accurate. If it's not, the scanner would obviously catch that. But then what will happen, or when it can get messed up, is they put the trowels on too early. And when they put the trowels on too early, the scanner can actually point out the high and low spots of where they're pushing concrete. So here on this wet concrete, you can start to see essentially it dips a little bit more than it should. But you can compare this to everything, even the aggregate floor, like you see here. So what this is showing you is everything in blue is between 2 or 3 inches away from top of finished floor. Everything in gold is 3 to 4 inches. So they kind of have a bulkhead raise so that they can do that. I can then create points off these regions if I want to start laying them out, and yeah, get an idea of what's there. For you MEP guys, if you can scan before the concrete's poured at a density, you should be able to pick up whether or not all your sleeves are there and do that comparison. As well as when stuff's going up, you can scan and compare to make sure everyone's in the right elevation. I have a couple examples just on screenshots showing you those. So here, what we're looking at is actually a fire sprinkler in a Cambridge job up in Massachusetts. The fire sprinkler guys, this was kind of a new build renovation in one of those universities. So existing steel, they were supposed to route around and then leave up an elevation. But we were on site with the HVAC that day. They didn't leave up an elevation like you see here. So you actually get an idea when you can jump into that to see essentially how far away they were versus installed. So you can use this at 2 points. You can use it to kind of be very fine detection, or you can see where things are going to clash as well here, where it's going to clash into the HVAC that was sitting on the ground and waiting to be installed. Another example is actually the tilt, and I will try and open this one just so we can see it, of a elevator core. So let me come back here. This is great because I just scanned every opening on a 10-story job here in Columbus, Ohio. And as it's going up, it's able to register and refine. You can start to see the tilt at the top 2 floors of the elevator core. So they're gonna have to grind down the area over there so that the elevator doesn't hit when it goes up. Open up that data real quick, sorry. And while that's opening, I'll show you the image. So everything in green here is, I don't know what that is within an inch. But as you start to see the blue, it's, I think, a 3-inch lean at the top there. And here's a picture. This image up here on the top right is actually showing you that HVAC example right here. As that's opening up, you can see for the mechanical guys, scan to T comparison on a job down in Virginia at VCU, at Mechanical Room there, where they actually laid out their points incorrectly, but were able to catch that. So they could see essentially the differencing of where this T joint was installed. And then they can adjust their prefabricated next part that's going to connect into this T joint right here. Because these pipes are, I think this was like at least 12-inch diameter pipes, they're able to still prefab and adjust those prefab elements so that it fits back in the field. So even if there was a mistake, they were able to catch it and then essentially fix for it before they ship out the next giant piece of pipe to then go up and install it. If I can come here, let me jump in just to show you a quick image. I actually like to show you kind of what the picture and scan looks like. So you could actually see this by looking at point measurements in between the two, as well as Z different elevations. Yeah, but that compute button works between just what you see here on the TZF. I can also look at a scan to model compute button. So I can actually click on a scan point and then click on a model point to see the differences. Let me jump back once here. I'll show you this data set later, but this is actually on site showing you from the screed over here to the trowel where the trowel lines are. But let's focus, I'm sorry, I lose focus fairly easy, but we'll focus on the elevator core here to show you how to do kind of a quick inspection. So by coming in here, creating a section view of just the back wall by essentially just dragging it to fit, I can then come in and run a comparison that you see down here as an inspection, and it'll create this cloud. And so this cloud here is showing me everything in green is within 1 inch, dark green is about 2, and blue there at the top is about 3 inches away. So it's great, and I think visually it looks great on flat or walled surfaces because they're bigger. But the same principles are essentially happen when you're looking at when you're looking at MEP stuff that maybe don't have the beautiful wall surfaces. So that's the inspection for that one. That what I was showing you here for the FFFL is also great. So here's just that same data. And if we change this to an elevation view, you can actually adjust the essentially the elevation it is showing you at and start to see the high and low spots on that concrete. So we'll repeat that. So kind of showing you the waves. And if we zoom in here, you can even see where that trowel is starting to push concrete versus where the screed kind of the lines in there. That's a lot of data. And I know we moved from project to project. I like to A, show live, and then B, hopefully show you it working on real projects. But I'm 4 minutes over. So I saw one question about the SD card, but any other questions or workflows questions, please submit them now. But that's it. I was hoping to keep this short so that everyone would it actually voluntarily come back to the next one.
Yeah, thanks, Steve. Yeah, if anyone has questions, feel free to put those into the Q&A box and we will answer those. If you are more comfortable in taking those questions offline, you can do so and reach us directly via email or through the contact us on our website. So if you navigate on our website to the X7 page and submit a question, that will make its way to the appropriate team members here on the Building Point Trimble side of the house.
Great. Well,
I also want to point out that this video, we will be distributing a link to this video for the webinar. If you want to go back to it at a later point, or you want to share it with maybe someone else in your company that wasn't able to attend, the link to the video will be sent out to everyone as well. And for any of those people that are current Building Point customers or have engaged with an account manager or account rep, you can certainly go to those guys with your questions. So okay. Brett is on, Corey is on, and Brian Gates is also on.
Got one question. When will the next webinar be? Among?
Our plan is to do it within 30 days.
Okay, and then what are the best setup for control points for the Trimble? So this shoots a red laser EDM. So typically, Gridline works. We sell a tilting target that actually kind of acts as a prism that you can put on top of a pole to shoot a normal surface. Those are typically the best if you can shoot it to a normal surface. And then hopefully eventually targets will be recognized, like black and white checkerboard targets. But for now, try and shoot to a normal surface within, it's 100 feet to do that setup.
Okay, well, if there aren't any questions, that's the other thing that you can expect from these webinars is they are going to be quick. Are all webinared to death over the last year, And so our goal is to get in and get out and deliver as much information and applicable information as we can in a short period of time, not to use up everyone's time. And if there is follow-up we need to do, we can certainly schedule a one-on-one with any of you if you have very specific questions related to your businesses. So with that said, I thank everyone for attending, and be on the lookout for the next webinar series number 2 in the next 30 days. Thank you, everyone.